Hi there! In this video, we will discuss Chapter 25 from the textbook Software Engineering by Ian Sommerville. The topic is Configuration Management. Our team consists of Alexis Ayuso, Dylan Jacobs, Britney McDonald, and Kersten Dismas. Now let's begin. Configuration management is concerned with the policies, processes, and tools for managing software systems. Because software changes frequently, systems can be thought of as a set of versions. Therefore, configuration management is important because without it, it is easy to lose track of what changes and component versions have been incorporated into each system version. Versions implement proposals for change, such as system requirement changes and new features. It implements corrections of faults, i.e. fix bugs, and adaptations for different hardware and operating systems. If you do not practice effective configuration management, it may result in wasted effort modifying the wrong version of a system, or delivering the wrong version of a system to customers, or even forgetting where the software source code for a particular version of the system or component is stored. The configuration management of a software system product involves 4 activities: version control, also known as version management, system building, change management, and release management. System building and version management both handle component versions and system versions. Change proposals are given during change management, which then alters system versions and system releases. Release management deals with system versions and system releases as well.
The first component of configuration management that we will discuss is version management. Version management is the process of keeping track of different versions of software components and the systems in which these components are used. It also involves ensuring that changes made by different developers to these versions do not interfere with each other. In other words, version management is a process of managing code lines and baselines. Since version management is a management of code lines and baselines, we first need to know what these are. A code line is a sequence of versions of source code with later versions in the sequence derived from earlier versions. Code lines normally apply to components of systems so that there are different versions of each component. Meanwhile, a baseline is a definition of a specific system. Baselines are controlled, which means that the component versions used in the baseline cannot be changed. However, it is always possible to recreate a baseline from its constituent components. The baseline specifies the component versions that are included in the system and identifies the libraries used, configuration files, and other system information. In the figure to the left, we can see that different baselines use different versions of the components from each code line. In the diagram, the shaded boxes represent components in the baseline definition to indicate that these are actually references to components in a code line. The main line is a sequence of system versions developed from an original baseline. Version control systems identify, store, and control access to the different versions of components. There are 2 types of modern version control systems. One being centralized systems where a single master repository maintains all versions of the software components that are being developed, and the second being distributed systems where multiple versions of the component repository exist at the same time. Here we note that to support independent development without interference, all version control systems use the concept of a project repository and a private workspace. The project repository maintains the master version of all components, which is used to create baselines for system building. The difference in the use of the repository is as follows. In a centralized system, developers check out the components or directories of components from the project repository into their private workspace and work on these copies in their private workspace. When the changes are complete, they check in the components back to the repository, and this creates a new component version that may then be shared. However, in distributed VC systems, a different approach is used where a master repository is created on a server that maintains the code produced by the development team, and instead of simply checking out the files that they need, a developer creates a clone of the project repository that is downloaded and installed on his or her personal computer, and developers work on the files required and maintain the new versions on their private repository on their own computer. When they have finished making changes, they commit these changes and update their private server repository. They may then push these changes to the project repository or tell the integration manager that changed versions are available. Repository cloning and independent development seen in distributed systems have several pros and cons. One advantage is that it provides a backup mechanism for the repository. So if the repository is corrupted, work can continue and the project repository can be restored from local copies. Also, it allows for offline working so that developers can commit changes if they do not have a network connection. Thirdly, project support is the default way of working, so developers can compile and test the entire system on their local machines and test the changes that they have made. However, a consequence of the independent development of the same component is that code lines may branch rather than a linear sequence of versions that reflect changes to the component over time. There may be several independent sequences. There are 5 common features of version control systems as follows. 1. Version and release identification. When managed versions of a component are assigned unique identifiers when they are submitted to the system, and these identifiers allow different versions of the same component to be managed without changing the component name. 2. Change history recording. The VC system keeps records of the changes that have been made to create a new version of a component from an earlier version. 3. Independent development. Different developers may be working on the same component at the same time, and the version control system keeps track of components that have been checked out for editing and ensures that changes made to a component by different developers do not interfere. 4. A project support. A version control system may support the development of several projects which share components. 5. Storage management, where rather than maintain separate copies of all versions of a component, the version control system may use efficient mechanisms to ensure that duplicate copies of identical files are not maintained. Where there are only small differences between files, the VC system may store these differences rather than maintain multiple copies of files. Storage management used to be the most important component of VC systems because disk storage was large and expensive. So in the past, what was done was a list of differences between older and newer versions was created called deltas, and these deltas were stored as lists of changed lines, and by applying these automatically, one version of a component could be created from another. However, reverting one version to another takes a lot of time, so some modern approaches now instead use compressed files, so all that is needed to retrieve the file is to decompress it.
The second topic we are going to cover under configuration management is system building. What is system building? It is the process of creating a complete executable system. by compiling and linking the system components, external libraries, configuration files, and other information. This is a diagram of system building. System building involves assembling a large amount of information about the software and its operating environment. An automated build tool is always used in creating a system build. An automated build tool is a software application that simplifies the process of creating a system build by automating repetitive tasks such as compiling source code, running tests, and packaging the final executable. These are the build system functionalities. Build script generation. It analyzes the program that is being built, identify dependent components, and automatically generate a build script or a configuration file. Version management system integration. Build system should check out the required versions of the components from version control system. Minimal recompilation. It works out what source code needs to be recompiled and set up compilation if required. Executable system creation. This links the compiled object code files with each other and with other required files. Test automation. Some build systems can automatically run automated tests using test automation tools. These are to check that the build has not been broken by changes. Reporting. It provides reports about success or failure of the build and the tests that have been run. Documentation generation. Build system may be able to generate release notes about the build and system help pages. These are the three build platforms. First, we have development system, which includes development tools such as compilers and source code editors. Then we have build server, which is used to build definite executable versions of the system. Last, we have the target environment. This is the platform on which the system is executed. This is the diagram of the build platforms. The development system is where the developers check out code from the version management system into a private workspace before making changes to the system. The build server, where developers check in code to the version management system before it is built. The system build may rely on external libraries that are not included in the version management system. Target environment. This may be the same type of computer that is used for development and build systems. However, for large systems, the target environment may include databases and other application systems that cannot be installed on development machines. In these situations, it is not possible to build and test the system on development computer or on the build server. So it is recommended that frequent system builds should be carried out with automated testing which are used to discover software problems. Frequent builds are part of a process of continuous integration, which is represented in this diagram. Continuous integration is an agile building process. This process involves rebuilding the mainline frequently after small source code changes have been made. This diagram demonstrates the continuous integration process. The developers check out the mainline system from the version management system into their private workspace, then build the system and run automated tests to ensure that the build system passes all tests. If not, the build is broken and the developer should inform whoever checked in the last baseline system, because they are responsible for repairing the problem. The developer then makes changes to the system components, then builds the system in private workspace and reruns system tests. If the test fails, they continue editing. Once the system has passed its test, they check into the build system but do not commit it as a new system baseline. The developer builds the system on the build server and run the test. They need to do this in case others have modified components since they checked out the system. If this is the case, they check out the components that have failed and edit these so that the test passed on their private workspace. If the system passes its test on the build system, then they commit the changes they made as a new baseline in the system mainline. Continuous integration process has its advantages and disadvantages. Some advantages of this process is that it allows problems caused by the interactions between different developers to be discovered and repaired as soon as possible. Another is that the most recent system in the mainline is the definite working system. The disadvantages are, if the system is very large, it may take a long time to build and test. especially if integration with other application system is involved. Another is that the development platform is different from the target platform and it may not be possible to run system tests in developer's private workspace.
Okay, I'll be talking about change management. What is change management? Change management is the process of weighing the advantages and costs of proposed modifications, approving the ones that are most cost effective, and keeping track of which systems components have been modified. Types of changes. There are several types of changes in change management. Number one, functional changes. Modifications to the features, functionality, or behavior of a system or process you want to discuss. Number two, technical changes. Updates to the underlying technology, infrastructure, or architecture. Number three, configuration changes. Adjustments to the configuration settings of a system or application. Number four, process changes. Revisions to workflow, procedures, or methodologies. Number five, data changes. Updates to the data structure, format, or content. Number six, organizational changes. Modifications to roles, responsibility, or reporting structures. This image shows the primary change management activities in a process model for change management. When the program is given to a company for development inside an organization or for distribution to clients, this procedure should be put into place. When a system stakeholder completes and submits a change request outlining the modification that needs to be made to the system, the change management process is started. This could be either a bug report that details the bug systems or a request for the system to add new functionality. Although some businesses handle bug reports and new requirements separately, both are just change requests. A change request form can be used to submit change requests. Owners and users of the system, such as beta testers, developers, or the marketing division of a business, are examples of stakeholders. In this diagram, the customer submits a change request, then the customer support checks the change request. If it's invalid, then it will close the change request, and if it's valid, it will register the change request. Development is basically the technical aspect of the change process, and implementation analysis and cost/impact analysis will be implemented here, and once those two are done, it will go to the product development team / the CCB, which is basically the business aspect of the change process, and they will assess the change request, then select the change request, and they will if it's worth it, then you will go ahead with it, or if you don't like it, then it will be, if it's costing more money, then they will close that change request, and okay, then if it does worth the time, they will go and modify the software, then test it, and if it's failed, then it will go back again to modify the software, test it, and if it passed, it will close the change request. This is the process of the change management. This is an example of a type of change request form that might be used in large complex systems engineering projects. But for smaller projects, it is recommended that change requests should be formally recorded. The change request form should focus on describing the change required with less emphasis on implementation issues. System developers decide how to implement the change and estimate the time required to complete the change implementation. After a change request has been submitted, it is checked to ensure that it is valid. The checker may be from a customer or application support team. For internal requests, may be a member of the development team. Factors in change analysis. Number one, the consequences of not making the change. This element evaluates the risk or adverse effect of not putting the suggested change into practice. It considers the ramifications of keeping the status quo as well as any mischances or difficulties that might result from not making the change. The benefits of change. This element assesses the potential benefits or advantages the organization might receive from the proposed change. It looks at how the modification might solve common problems, boost productivity, restructure workflow, or provide organizations a competitive edge. The number of users affected by the change. This element considers the size and scope of the change as well as how many users or stockholders it will affect. It aids in estimating the amount of work needed for support, training, and communication before, during, and after the change implementation. The cost of making the change. This consideration entails estimating the cost in terms of money, resources, and time for carrying out the modification. It considers the financial outlay needed for preparation, creation, testing, training, and any potential setbacks during implementation process. The product release cycle. This factor looks at the organization cycle for releasing new products. It evaluates whether the suggested change can be successfully incorporated into the correct development cycle or whether it necessitates changes to the schedule and release plans. Agile methods in change management. In some agile methods, customers play a direct role in deciding whether a change should be implemented. Customers propose changes to the system requirements. They collaborate with the development team to assess the impact of the change. They prioritize the change against planned features for the next increment of the system. Software improvement changes are left to the discretion of the programmers. Refactoring, which involves continuous software improvement, is considered an integral part of the development process. Programmers have the autonomy to make necessary software improvement without explicit customer involvement. Maintaining a record of changes made to each software component is important. The record is referred to as the derivation history of a component. A standardized comment at the beginning of the component source code is a good way to keep track of the derivation history. The comment should reference the change request that trigger the software change. For documents, records of changes incorporated in each version are maintained separately. In the case of documents, changes incorporated in each version are documented on a separate page at the front of the document. This helps in tracking the evolution of the document and understanding the changes made over time. Derivation histories can be processed by scripts to generate component change reports. Script scans all components to extract the derivation histories. Component change reports provide a comprehensive overview of changes made to each component.
The final activity of configuration management is release management. Release management involves preparing software for external release and keeping track of the system versions that have been released for customer use. A system release is a version of a software system that is distributed to customers. For mass market software, there are two types of releases: major releases and minor releases. Major releases deliver significant new functionality. For example, iOS 13. Minor releases repair bugs and fix customer problems that have been reported. For example, iOS 13.2. A software product release includes the executable code of the system, configuration files, data files such as files of error messages in different languages, an installation program, electronic and paper documentation describing the system, and packaging and associated publicity that have been designed for that release. Factors influencing system release planning include competition, marketing requirements, platform changes, and the technical quality of the system. Competition involves keeping up with new features from a competing product. Marketing requirements involves applying marketing strategies that convince the customer to buy the new release, as well as a balancing release timing. Platform changes requires creating a new release of a software application when a new version of the operating system platform is released. The technical quality of the system is correcting system faults. Okay, now let's recap some key points about configuration management. Configuration management is the management of an evolving software system. The main configuration management processes are concerned with version control, system building, change management, and release management. That is the end of our presentation on configuration management. Thank you for listening.